In today's note, we are going to look at a method called completing the square when a equals 1. So completing the square comes into play because we've seen two forms of a quadratic equation. We've seen the standard form, y equals ax squared plus bx plus c, and we've recognized, or hopefully we recognize, that there's not much useful information from this form. We know that the a value tells us the direction of the opening in the step pattern, and that the c value tells us our y-intercept, but it doesn't tell us anything other than that. Our vertex form does tell us our vertex as well as the a value, our axis of symmetry, our optimal value. We can expand it to get it into standard form, and then basically find our y-intercept as well. The a value is still the same. So it is going to be helpful to get our quadratic into a vertex form, especially for questions where we're looking for the maximum or the minimum value, right, or that optimal value. That's usually the most important part. So if we can find that, then that is helpful. And what we're going to do in order to do that is complete the square. So again, that's going to allow us to convert from standard form to vertex form. So the steps we're going to go through, I'm going to read through them first, and then we'll break it down and go through a couple of examples. The first step is we want to group the first two terms, and this will be the x squared and the x term in our standard form. We then want to make a perfect square trinomial inside the brackets. In order to do this, we need to have a magic number. We get this magic number by dividing the second number, or the coefficient on x, by 2 and then squaring it. So we can see over here, this is basically the formula for finding the magic number. Once we have that magic number, we're going to add it and subtract it into our equation inside the bracket. By adding it and subtracting it, we're not really changing anything. We're going to move the subtraction part outside of the bracket, and whatever's left in the bracket should be a perfect square trinomial. We're going to factor that, and then we're going to collect like terms, and in the end we should have our vertex form. So in the first example, I want to change the following into vertex form by completing the square. So the first step, I'm going to put brackets around the first two terms. The second step, I need to find my magic number. So I'm going to take this second value, or the second number, in front of the x. I'm going to divide it by 2 and then square it. So here I get -2 squared, which is 4. You can include the negative. You don't have to include the negative, because in the end, when you square the number, regardless of what you have, positive or negative, it's always going to end up positive. Let's keep the numbers the same. Step 3 says to add and subtract the magic number inside those brackets. So we have y equals, then x squared minus 4x. I'm going to add and subtract this, so plus 4 minus 4. And then the plus 5 is still outside the bracket. Step 4 says to move the subtraction outside of the bracket. So we're going to be left with, inside our bracket, x squared minus 4x plus 4. The minus 4 is now outside the bracket with the plus 5. Our last step is to factor the perfect square trinomial and collect like terms. So in the end, we get y equals, in the bracket is the perfect square trinomial, and it becomes x minus 2 squared. You can also think of it as that middle magic number we see over here. So that second step, that's the last value in our bracket with x. And then we can collect like terms outside of the bracket. So the minus 4 plus 5 is positive 1. And this here now is our vertex form. So we could graph this. We could find the optimal value, which is plus 1. We could find the axis of symmetry, which is 2. We could again find the a value, which in this case, or all these examples in this lesson, will be 1. And we could graph this if we wanted to. So a lot more information than the standard form. So moving on to another example, we're going to do the same thing. The first step, I want to put brackets around the first two terms. The second step, take that second number, or the number in front of the x, so 6 divide by 2, and then square it. So 3 squared equals 9. Step 3 says to add and subtract that magic number into the bracket. So plus 9 minus 9. And then outside the bracket is still that plus 2. Step 4 says to move that subtraction outside of the bracket. So we're left with x squared plus 6x plus 9. Outside of the bracket, we have the minus 9, still have plus 2, and step 5 now says factor the perfect square in the bracket and collect like terms. So inside my bracket, it will be x plus 3 squared. Again, I can take that second step of my magic number to find what that value with x will be. And I can collect my like terms. Minus 9 plus 7, or sorry, plus 2 is negative 7. So now I have vertex form in step 5. And again, if I wanted to know my optimal value or the axis of symmetry or graph this, I could because I know all my values needed. If you don't remember how to graph this vertex form, please review the previous lesson on vertex form, going from the equation to the graph. What we're going to look at next is 2 more examples. So I'm going to pause the video, give you a chance to try these on your own. Again, go through those 5 steps. They're the exact same steps for both of them. And hopefully you get to the right to the right vertex form. So coming back to these 2 examples, these are your final solutions that you should have in step 5 for both of them. So for C, your vertex form should be y equals x minus 5 squared minus 8. And for D, your vertex form should be y equals x plus 4 squared minus 1. So again, follow through those 5 steps, find the magic number, add and subtract it to your bracket, move the subtraction outside, and then factor. Again, if you have trouble factoring, it should always just be x and then plus or minus whatever that second step or that second number happens to be. So go back and we'll put stars next to those ones. Right, so then that second step of finding the magic number, that tells you what's going to be in the bracket with x. So if you don't quite remember how to factor perfect square trinomials, that's a shortcut you can use. All right. Moving on to number 2. So a bird is sitting on a tree branch and dives into the water to grab a fish. The path of the bird can be modeled by h equals x squared minus 12x plus 30, where h is the height in meters and x is the horizontal distance. A wants to know what is the height of the branch the bird is sitting on. So another way you can think of this, you could think of it as the starting height. And there's two ways you could do this. You could do this algebraically using the equation you're already given, or you can use your understanding of the standard form. But essentially what this is looking for, it's looking for the y-intercept. And in this case, from standard form, it's the c value. And in this case, c equals 30. So therefore, the height is 30 meters. So the bird's sitting at 30 meters and then is going to dive into the water to grab a fish. In B, if the bird grabbed the fish at the lowest point of its dive, how far below the water did the fish grab the bird? And what is the horizontal distance? So thinking about this, we have kind of a general idea of this graph. We know it's going to look something like this, with kind of the starting point at 30. It's going to land to the water. It's my bird, and it's going to grab a fish. So just to kind of help you visualize what's actually happening here. Bird's going to dive in, grab the fish, and then come back up. We want to know what is the lowest point of the dive. Or in other words, when we're talking about the lowest point, we're looking for the vertex, or more specifically, the optimal value. Right, 'cause remember, the optimal value was your max or min. So that's what we're trying to find, and then same with the horizontal distance. Right, that's coming from our vertex as well. So what we have to do is we have to take our equation and convert it into vertex form. So the first step, I'm going to take my equation, h equals x squared minus 12x plus 30, and I'm going to put brackets around the first two numbers. My next step, I'm going to find my magic number. I'm going to take that second value, or the negative 12, divide it by 2, and then square it. So here I get negative 6 squared, which equals 36. Now that I have that magic number, I can add and subtract it inside my bracket. So x squared minus 12x plus 36 minus 36, and then plus 30. Step 4 says I need to move that subtraction outside of my bracket. So x squared minus 12x plus 36 is going to remain inside the bracket, and then outside the bracket I'll have the minus 36 as well as the plus 30 from my initial equation. The last step is to factor the bracket, which should be a perfect square trinomial, because that's why we completed the square. Again, the value that we're looking for, let me just move this over a bit. The value that's going to be in the bracket with x comes from that second step. So in this case, we have x minus 6 squared. Collect our like terms outside that bracket. We get negative 6. And that is my vertex form. So from this vertex form, we should get that our vertex is 6, negative 6. So in this case, this is the lowest point on my graph, or on my quadratic. So the question's asking, how far below the water did the fish grab the bird? Well, looking at the optimal value, or the horizontal or the vertical distance. So therefore, the fish grabbed the bird 6 meters below water, because that's my y value. 6 meters below the water and we can say with a horizontal distance of 6 meters, which is the x value. So again, we use the vertex form to find our optimal value. We've converted to our vertex form by using completing the square, which allows us to go from standard form to vertex form, and it allows us to find that optimal value. So again, go through those 5 steps to convert from one form to another. This will only work these 5 steps, will only work right now when the a value is equal to 1. So every x squared that you see in this lesson and these practice questions, the value in front of the x squared should equal 1. In other words, you shouldn't see a value there. Our next lesson, we are going to look at how to solve these types of problems when the a value is not 1. And it's very similar, but don't worry about it for right now. Just focus on these 5 steps for when the a value equals 1.